Hello students, today we are discussing PV diagrams. We get one MCQ from PV diagrams. If you have noticed the past papers, you must have seen this. So today we are discussing PV diagram question models, the type of questions. Right, so basically this question actually based on thermodynamics. So you should know the thermodynamics theories for sure. Delta Q equals delta U plus delta W, and we have, yes, isothermal and adiabatic expansions. So these are the things you should know before doing the questions, but there are a couple of things you should know when you are doing the question when it comes to the PV diagram graphs. So let's discuss the question models we have, and then at the end of the lesson actually I'll be giving you 2 or 3 questions. So let's try these questions as well. So just try these type of questions. You'll be getting 1 mark out of 50 from MCQ. So altogether it's 1 mark out of 100. So it'll increase your marks for sure. Let's try it now. Right. As we discussed earlier, let's talk about the question models we have now. Basically, these questions we start with isothermal and adiabatic questions. Right. Adiabatic questions. Right. Isothermal and adiabatic you should know. Actually, these expansion A to B, it's an isothermal expansion. A to C, it's adiabatic expansion. The gradient is a bit lower in it bit higher actually in adiabatic expansion. Right. So basically, adiabatic expansion delta Q equals delta U plus delta W is the basic equation we have for thermodynamics. So here delta Q is the heat exchange from environment, and delta U is the internal energy change. Right, internal energy mean actually a temperature change. Right, if there's a temperature change, internal energy is changed, and delta W is net, actually it's the work done. Right, so once we add these two, we get the heat exchange from the external environment. So in isothermal process, yes, you know delta U is 0, and in adiabatic process delta Q is 0. Other than these things, we need to know a couple of things to identify isothermal and adiabatic. Is if it's isothermal, it's a quick, it's a slow process, and on the other hand, in adiabatic process, it's a quick process. So these are the actually the tips that are being given in the paper, actually in the question. So you have to understand the cue there. Right. Moving into the question now, model 1. So in PV diagrams, you can see they are giving us from A state to C state. The question is the gas is changing A to C, and there are 2 paths. So in these questions actually they are asking us to find the work done from A to C path or A B C path. In which path the maximum work is done. Right, from A to C there are 2 paths, so in which path the maximum work is done. So you can easily, you have to take the area under the graph. So if we consider A B C work, actually BC work, basically it is the area under that. So it's actually this value, right. And here one thing you need to know, if there's no change in volume, so no change in volume, here you can see AB path, this path, and there's no change in volume, so no work is done. So if we consider ABC path, only the area under BC curve is the work done, and on the other hand, the area under AC is the work done by AC path. So here you can easily see that ABC, actually BC path work done is higher. Right, this is the question model 1. Right, moving into the model 2. Right, in this one you can see, I hope you can see it, it's a cyclic process. It starts from A and ends again at A. Right, so basically in these type of question they are asking us to find the net work done. So basically net work done is the area of this enclosed area. Right. On the other hand, yes, we will be getting statement question asking the final temperature is equal to the initial temperature, or what happens to the delta U, internal energy change, that's 0 if it comes back to A again, and net work done, the temperature change throughout the process. Likewise, there are tricky questions in these type of questions. And again, you have to consider the direction of, yes, direction of these arrows. So we get clockwise and anti-clockwise. This is anti-clockwise. Yes, clockwise we consider it's plus work done and heat absorbed, and anti-clockwise we consider it's minus and energy is liberated, right, absorbed and energy is liberated. So these are the points we need to remember when doing a question like this, right. Moving into the other model. Yes, here remember when you are getting a question like this, they are giving you the data here. So that means we have to use the data. Basically remember that we have to use the data. So temperature, they are asking us to find, compare the temperatures A, B, C likewise. So which temperature is highest, A, B or C? Let's say TA, TB and TC. In this way they are asking which temperature is highest. So here in this manner we need to find the point PV value here. So it's 3 into, actually 3 into 10 to the power 5. So 3 into 10, that's basically 30. In B it's 2 into 20, that is 40, and C actually it's 1 into 30, again it's 30. So highest PV value will be, yes, for B. So that means the highest temperature will be TB, and of course TA and TC are equal, right. You need to know these things, right. So moving into, this is actually a past paper question we've got in our A levels 2015. So this question actually they are asking us to find the temperatures. So which temperature is the highest, which temperature is the lowest. So basically what you have to do is you have to multiply these values, PV values, and see which one is the highest. So if you haven't done this question, just go ahead and try the question. I'm not going to explain, but try this type of question. This is actually from the question model 3, right. Moving into the fourth one. Actually in this delta Q, delta U and delta W, these are the basic points. Actually they will be getting a table or something saying this is plus, this is minus, and this is 0, this is plus, likewise. So what we have to basically understand is, from their explanation, from the question, we need to identify whether this is isothermal or adiabatic. So what basically happens is, if it's isothermal, delta U has to be 0, and these two values will be getting the equal marks. And if it's adiabatic, what happens is these two has to cancel off, and basically delta Q has to be 0. So either plus minus or minus plus, these two has to cancel off. So these point actually we need to consider in the fourth question model. Alright students, this is the very first question I am giving you. Actually this question contains couple of question models. Actually we discussed earlier. So I'll give you a couple of minutes for you to try this question, and then let's discuss it furthermore. So I'm suggesting you to just try this first and let's discuss it later, right. So I hope you have tried it. If you haven't tried it, just stop there and try the question, right. Let's get into the answer now, right. Here see what are the data they have given us. So PV curve, it's basically an adiabatic expansion. That means delta Q, it has to be 0, and delta U plus delta W 0, right. And the work done by air from A to B and B to C, right. So finding work is easy, because what you have to do is you have to find the area. This is the AB work and this is the BC work. So what you have to do is you have to find the area of these two trapeziums, right. So 1 and 2. So find this value, you will be getting 44 and 78. Then the next problem. So this is 78 and this is 44, right. So which one, whether they are positive or negative, that is the question you will be having now, right. So you can see here delta Q and delta W, it has to be 0. So let's see whether delta U value is positive or negative, right. From A to B, we need to identify what happens to the temperature. So I have told you earlier, it's PV values, point PV values. So PV values at these 2 points, right. So let's multiply these values and see. So 2 into 1, so basically the PV value here is, it's 2, and at point B it's 1.6 into 1.2, so it's 1.92, right? So then 1 into 1.4, it's 1.4. So what you see here is the delta Q value, that, yes, that goes down. Delta U, it will be a negative value. So A to B, yes, delta U is negative, minus. So that means delta W value, it has to be a positive value. Then these two cancel off and it will be 0, right? And then B to C, again it's 1.92 to 1.4. It will decrease the value. So again it's negative, so it's positive. So 44 and 78. So answer is the first one. Right, moving into the second question. Actually it's a past paper question. I just wanted to show you the simple questions actually. So consider, let's just try the question. It's a very easy question. Just try it and come back for the explanation. Just hold it there and just you can easily get the answer. Right. Right, moving into the explanation part. Consider a process where air is quickly leaking out of a balloon. Which of the following is true for this process? Right. So this is the point actually I'm taking, quick. That means it's an adiabatic process. Adiabatic process. That means delta Q, it has to be 0. So all these three are correct. Right. Then, as I said earlier in the question models, delta W, once we add delta W and delta U, it has to be 0. So these two has to have opposite signs. So no, yes, no chance, and again no, and here the last one you can see is plus and minus, so it will cancel off. That's the answer, fifth one. So it's easy, it's an easy question, right? Moving into the other question now. Alright kids, moving into the third question, right? Just go through with this question. Actually this is from PV diagram and PT diagram. So just try the question, take a minute and try this question and let's discuss. Alright, moving into the discussion. If you haven't done, just try it again. Okay, a pressure PV curve, a constant mass of air, is shown in the figure. The corresponding graph showing the variation of pressure versus absolute temperature T here, right? So again, this is basically you have to do from PV values. See, the PV values of D is PV values of point PV values, I mean the pressure into volume. So A value is greater than B value. So PV value is at A is greater than value at A. So that means the temperature of B is greater than A. 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 Is still the fourth one. Pressures are not equal. Pressures are not equal, so it's wrong. Right. These four are correct. Right. Moving into the second part. BC, you can see it's a curve. Actually, we cannot directly give an idea about PV values of C and PV values of B. So we can get the idea, yes, BC temperature, this can be an isothermal process. So BC, so temperature can be, volume goes down, pressure goes down of course, but temperature, let's assume it's the same. So still we have two answers, second one and third one. Then see here they are telling it's a smaller temperature, but we cannot argue with that. Let's see the third one, C to D process. Actually what you can see, PV value of D is smaller than at the value at C. You can easily see that. So temperature will go down. That's basically C to D, C to D. And the pressure at D, we can easily see pressure at D is smaller to A. So it's the second answer is the most probable answer you can see. The temperature of B and C, we have to assume it has 0 because the PV curve, it shows like this. Basically it shows isothermal process, but they are not telling it isothermal or anything. If PV value at B and PV value at C are equal, it's the most probable answer is the second one, right? Alright students, I hope you have tried these questions now, and the question models, actually go through with the question models And remember that there's a high chance we are getting a there's a PV diagram question we will be getting. So basically try the past paper, at least there are many past paper questions. So try these questions, try your school paper question, try your model paper question that you have given, you have got from your classes and all that. So this question you can easily get the 1 mark. So go for that mark. You can easily score this at the exam, right? Good luck.